Hello all, welcome back. And today's discussion is about minimum spanning tree. So what is a minimum spanning tree? Generally it is a spanning tree with the minimum possible total weight, or we can say it is a spanning tree with the minimum weight among all the other possible spanning trees. Okay, that is what the minimum spanning tree. But what is a spanning tree? First, we should know what is a spanning tree. So, what is a spanning tree? Spanning tree is a graph. You can say it is a subgraph. Okay, a graph or a subgraph. Okay, and that doesn't contain any cycles in it. Okay, which doesn't contain any cycles in it. So, contains any cycles, okay, in it. So that is what called as a spanning tree. Okay, that is you are given with one graph. Okay, so that graph can be a cyclic graph or an uncyclic graph, but from that graph what you're going to do, you're going to construct a subgraph. Okay, and that subgraph that doesn't have any cycles in it, then that graph is called as, that subgraph is called as what? A spanning tree. Now coming to minimum spanning tree. So when do you go for minimum spanning tree? When the spanning tree has some edges. Okay, you need to find which spanning tree is having minimum number of weight, that is total cost of the spanning tree should be less, okay, compared to other spanning trees. So which means for a graph how many spanning trees we can form, okay, we can construct. So we'll see one example for that. So here I have taken an example like a graph that contains three vertices, okay, that is A, B and C. Now I need to construct spanning tree for this given graph. Okay, so which means I should construct a subgraph, and that subgraph shouldn't have any cycles in it. So what are all the possible spanning trees that can be generated from this given graph? So how do I generate a spanning tree for this? Let me take all the vertices. So all the vertices should be visited in this graph. Okay, I'm going to visit all the vertices but without forming any cycle. So what shall I do means, this is my spanning tree for this graph. Okay, I generated a spanning tree for this graph, and you can see there are no cycles in this graph. Okay, this is one spanning tree. Likewise, I can also have one more spanning tree for this. Okay, that spanning tree will be this one. This is my second spanning tree for the same graph. Okay, so we obtained one more spanning tree, right? And here also we have visited all the vertices without forming cycle. And can we form one more spanning tree for this? Yes, we can able to form another spanning tree for this just by taking these two edges. Okay, so this is my third spanning tree for the same graph. Okay, so for this graph containing three vertices, here I got three spanning trees. Okay, three types of spanning trees, and you can see all these spanning trees are different from each other, but here you are visiting all the vertices and not forming any cycles in it. And if you look at here, whenever you have a spanning tree, always the number of edges is equal to number of vertices minus 1, because there are three vertices here and the number of vertices is, number of edges are 2. In the same way, in this graph also we have three vertices and two edges. Here also three vertices and two edges. So always edges, okay, number of edges is equal to what? Number of vertices of the graph minus 1. So this is what the number of edges of a spanning tree. Okay, remember this formula. Okay, whenever you are constructing any spanning tree, so this formula you need to remember. Fine. So this is what a spanning tree. Now coming to minimum spanning tree. So how do we find minimum spanning tree? See, this graph is actually an unweighted graph. Okay. What if this graph has some weights like this? Okay. So this is the graph which has weights on the edges. Okay. And this edge is having the weight 3. This edge has a weight 4 and this edge having weight 6. Now in all these spanning trees, again you need to have all the weights on the edges. Okay, here 3, here it is 6, and here it is 4 and 6. Now if you calculate the total cost of these spanning trees, okay, so what would be the total cost of this spanning tree? That can be 7, and the total cost for this one is 6 plus 3 9. And what is the total cost of this spanning tree? 6 plus 4 10. So for this subgraph, oh sorry, for this graph I have these many spanning trees, right, and all the spanning trees containing some total cost, and among all these spanning tree, which spanning tree is having the minimum cost? So this spanning tree has the minimum cost here. Now I can consider this as my minimum spanning tree. Okay, that is what you are going to find in this problem. Okay, you are going to find the minimum spanning tree for a given graph. Okay, and when you want to find a minimum spanning tree for this graph containing 3 vertices, again you need to find 3 spanning tree, and from this 3 spanning tree, which is the minimum, you need to find. Okay, what if the number of vertices are more? So if the number of vertices are more, then we do not know how many spanning trees we need to form, and among all those spanning trees, again we need to find which is having the minimum weight, that is minimum cost. So it is basically a difficult process to do, right? You cannot generate every time a spanning tree, and you cannot check for the minimum spanning tree. So for that reason, here we have 2 algorithms to find the minimum spanning tree. So there are 2 algorithms to find minimum spanning tree. So the first one is Kruskal's algorithm, and the next is Prim's algorithm. So we'll discuss about these 2 algorithms in our next videos.